This is problem 7 of the 2018 AMC 10 test B. All right, and what I noticed is the test B is a lot harder than test A for some reason. So I had trouble kind of solving this problem, but let me take you through the steps. All right, so it took me about 15-30 minutes to solve this problem. Right, it took a little bit longer. Okay, but here's how we solved it. Okay, so it says in the figure below, n-congruent semicircles lie on the diameter of a large semicircle, with their diameters covering the diameter of the large semicircle with no overlap. Let A be the combined area of the small semicircles, and B be the area of the region inside the large semicircle, but outside the semicircles. The ratio A to B is 1 to 18. What is n? Alright, so it says B is this area, and A is the area of all these semicircles combined. Alright, so there isn't necessarily 8 semicircles. This is just what they're asking. This is what they're kind of modeling for us, okay? And so they're asking us what is n, okay? So let's try to solve it. N is the amount of semicircles here. Alright, so first of all, let's see what they're asking us, okay? So let's call the radius of each small semicircle, let's call that n, okay? Or I'm sorry, let's call that r for radius, okay? And let me just refer back to my paper here. Alright, so if we refer that to r, and now the area of one small semicircle is going to be pi r squared, right? It's pi r squared divided by 2, right? Because this is a semicircle. Okay, and if we want to find the area of all of these, alright, so all of the semicircles, well, n is just the amount of semicircles, so we're going to multiply the area of one semicircle times the amount of all the semicircles, which is n, and that'll get us the area of all of these combined, or in other words, it'll get us the area of the letter A, alright, it says right there. And so B is the area of the region inside the large semicircle, but outside the semicircles. A to B is 1 to 18. Alright, so we can't necessarily find B algebraically, but what it's telling us here is that the ratio of A to B is 1 to 18. So we know that B is just 18 times this. Alright, so this is equal to A, and B is equal to 18 times n times pi times r squared divided by 2, which is just going to be 9 times pi times r squared. Alright, 9 pi r squared times n. Okay, so this is what we have. And so they're telling us to try to find the value of n, okay? And so how do we do that? Well, so let's try to find the value of, what's the value of this whole semicircle right here, right? So how do we find that value, okay? Well, we can basically deduce the value of this, the radius of this large semicircle to n times r, right? Let me tell you why. So if we have r of one of these, and we have n of these semicircles, well, if we just multiplied n, the amount of semicircles, to r, the radius, well, we'd go all the way down and then stop halfway here, right? Because that's we're finding out the radiuses, all right? So we have n times r is the radius. If you don't understand why n times r would be if you still don't understand why, just try to rationalize it inside your head, alright? It took me a long time to really wrap my mind around that concept, alright? But just know that if we were multiplying the small radiuses or radii, whatever you call it, of these semicircles, if we multiplied that n times, you go n, or 1, 2, 3, all the way down to n, and that'll be the middle, alright? So n times r. So this is the radius, and we know that if this is the radius, then we'd have to square this to find the area. So squared times pi. Alright. And remember, we have to divide by 2. Then so they're telling us this is the whole area of both A plus B, okay? And so all we have to do is A plus B, which is right here, A plus B. And so if we added these two together, we would get what would we get? Remember, this is just 18 over 2, so we would get 19 over 2, and then pi r squared n. Alright, and these 2's, they can just cancel out each other. So if n squared times r squared times pi is equal to 19 pi times r squared times n. We can rule out these r squares. We can cross out the pi's. And so then finally what we have is we have 19n is equal to n squared, alright? And so clearly from this, we can deduce from the fact that divide n on both sides, and we'd have n is equal to 19, and that is clearly stated in this answer right here, right? So if you're having trouble with solving this problem, what I did is I just rationalized everything, right? So why would this be true, right? How would this work out? So just if you're having trouble, just assign a given value, alright, given value to any of these radii or whatever, and I think when you assign that given value, everything will be proportional to each other, and you'll be able to solve the problem. Alright, there you go. That's how you solve it.